Hey guys, Shravan here. Hope you all doing well. In this video, we will cover a linear regression problem, uh, which is basically predicting chances of getting admission in a particular university. I have already made a video on this. I'll provide the link in the description. In this video, like extra thing that I am doing is like saving the model and then deploying the model using TensorFlow survey. And also we are going to build a Flask application with a simple UI to give the information of the student, to give student details and then get the prediction. So let's do this, guys. Let's start. Okay, so this is the dataset that we are dealing with. You can find it in the GitHub repository, and yeah, that previous video, this is the file on which I made a video. I'll provide it in the description as I said. Okay, so this is the thing. So actually I have in the previous video that I forgot to remove the index column. We'll rectify that in this file, sorry, in this project. So I'll basically copy our previous work to my main file, and then we'll just go through entire file. So this is the URL that we just saw, dataset URL. Okay, target is admit and categorical columns research. Just keep this in mind, the research column that we have made it as a categorical column, and we'll remove out all the printf, unnecessary printf, and we'll just separate dataset into train and validation data. Then remove the label from the dataset, and also we'll as I said, we'll remove index column also from the both train and valid data frame. I'll just pop it out, pop index. This will affect our prediction, so we'll remove it, and then scaling the data frame. So in my previous video, like as you have seen, like we have scaled the dataset using the stats data frame. So we will just save the stats into stats.csv file in the temp directory. We'll get to know why we are doing this. This is mainly when we build the Flask application, we'll be using this stats file to actually scale the data that we get from the form, like to scale the new data and then get the prediction, or else we'll see if we are not scaling, then we'll get very bad results. We will see that in this video. Prepare dataset, and then we'll prepare training and validate dataset. Is basically in the TensorFlow data format, data type. We'll build the model, simple model, and then we'll compile it with MSC loss and SGD optimizer function, and then we'll train the model for 10 epochs, passing training dataset and validate dataset. So then we'll plot training and validation loss and MAE. This is pretty straightforward, and then we'll make a prediction for the sample data that we have already stored in prediction data. Now let's run this. Okay, the graph looks fine, and as you can see, the prediction is also we're able to get the prediction, and then the code is working fine. So we'll just see the stats .csv file, stats.csv. Okay, so here we have mean and the standard deviation data for each individual column. We'll be using it in our Flask application to normalize the new input data. Okay, so So sanity test is done. One more thing that we can do to test our model is to split the data into split the valid dataset into valid and then test. So we'll just do that. We'll just further divide valid data frame into valid data frame and test data frame. So validation, okay, validating. No, something is wrong. Okay. So this is wrong. 1 second. I should be. Yeah, I should be splitting validation, not trained data frame. So let me just rename it to validation, and then I'll split to valid df validation sample. I'll split into 90% instead of 85%. Then test data df. I'll just remove all the validated data frame index from the validation data frame. So now we have 3 data frames: train, valid, and test. Now we'll also remove index from the test. Pop index, test labels, and also remove test labels. Pop target and then values. Okay. Again, we'll just repeat this process. Normalize test data frame. We'll subtract it with the stats of mean and then divide it by stats of standard deviation. Okay. Now we'll create test data. Norm test data frame to numpy. Okay. Now let's prepare test dataset. Test dataset. Prepare dataset. Test data. Test labels. Batch size and then buffer. Okay. I think we are done with preparing the dataset. Now the final thing that is left is to evaluate our model using test dataset. Also, what we'll do is we'll, instead of just training it for 10 epochs, we'll train it for a very longer value, and then we'll stop the training with early stopping TensorFlow callback. This is a very useful way of doing. We will monitor validation memory, and then whenever it decreases, whenever it tries to increase, we'll just stop the training loop. Early stopping will pass in callbacks for in the model.fit function. Then rest everything is same, and then let's evaluate our model using test dataset. Evaluate pass test dataset. Okay, let's print it. Evaluation. Loss in evaluation will be getting loss and MAE value. Okay. Evaluation. Okay, let's run this program. Okay, now you can see here it is training for a longer iteration. So it is trained for 101 epochs, and this is the loss and the MAE value. Okay. 1000. Okay, 1000. Okay, I'll just comment this part and then we'll just note down each evaluated model metrics. I'll just copy this and then paste it here. This is for just 10 epochs without early stopping. Without early stopping. And just 10 epochs. The loss and MA values such. Now we'll uncomment it again. Let's see the value. 1000. Let's run this. Okay. 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 So we can see MA is loss and MA are less compared to our previous result metrics, that is only for 10 epochs. Now let's also try this by modifying learning rate. Let's just experiment for a while. LR 1001. Now let's run the training loop. Okay, now I can see it is running for a longer time. Okay, it has gone past 300, 400, 500, 600, 700, 800, 900. Okay. Okay, this is the value. It has not much improved actually, so I think we will comment out the learning rate to the default one. So, okay, we'll go with this setup. Okay, now let's what we'll do is we'll save the model now. Let's save the model. Save path. I'll just save the model into temp directory. I will save it into regression model. Okay, now let's import OS and OS library. Okay, let's check if the directory is already created. Yes. Okay, I'll import SHUTL. Okay, let's let's just remove it, and then if not, we'll just create the directory. Save path. Okay, now we'll just save the model. We'll save the model. Python main. Okay, graph looks okay. Okay, it is done. It is saved in the /temp regression model. Let's just check. Okay, guys, our model is successfully saved. Maybe now let's look into uh, building up a web application using Flask. Okay, now let's build our Flask application. So this is our saved model and then web application. I have just uh, created a no, blueprint for us to develop the web app. I have created I have written a blog on this as well for how to create this folder structure for Flask. I'll also mention provide the link for that article. It's a Medium article. I enjoy writing coding in this directory structure. Okay, let's just see what are the files that we have. So admissions controller, we'll have a controller, and then we have only basically one controller, that is admissions controller. We have defined it in the init file. Like we have defined a blueprint for our admissions controller to have get and a post API. So in the views I have base HTML, index HTML, and show HTML. In the base, we have to do the to do part, and index nothing is there. We'll just extend the base, and then show is also same. Nothing much is there. We'll just build this currently. So let's just run this app to just check if it's fine. Okay, localhost, so to do, it's working fine with nothing in it. So nothing is there in a controller or the views or in the prediction helper file. Let's just open some bootstrap form. Let's take this form. I'll just copy entire file and just paste it in here. Okay, I'll remove the checkbox which is not required for us. This is just a simple form that I'm going to build. You can customize it the way you want. Yeah, let's just remove this password also. We'll just focus on only one field for now. We will take out this email. I'll take in GR score to test GRE, and the type will take number. Email GL to press it with GRE score. Okay, so method is a post call, and then action we will redirect it to admissions dot index URL for admissions dot index, that we have already defined it in the init function, init file. Slash is will be routed to index function. So this is the index function. So post method, whenever that is a post method, it goes inside that if condition, or else just passes on. Okay, now let's just refresh it. Okay guys, we have done a base. Okay, let's just rename it to student, or rather details student. Okay. I think we're done with this simple setup. We're able to do a post call as well. Now let's just print what comes out from the form. Print request dot form of our field GRE. Let's just type something. Okay, 1 2 3 is printing here, so everything is working fine shine. Now let's define our prediction function. We'll define we'll move all the code for the prediction into helpers. We'll create a function called predict chances in the prediction file. Let's do this. Predict chances, and we'll pass in request object from the controller. Okay, I don't want to make any spelling mistakes. Let's just copy paste this. Okay, let's just copy paste this to avoid spelling mistakes, and then we'll define another helper function which returns me all the parameters from the form. Request, and then params will just define params, initialize it to empty array. Fields will just for now we'll define only GRE. Categorical fields, it's research. If you remember that I had stressed this part in while building our regression model. Categorical fields. So in the fields, request dot form dot get field, and then if we have a value in it, we will append. If not, we'll just for now send it to 0, or else we'll just append it to param value. Okay, now we'll do the same thing for categorical. I'll tell you why we do this separately. It's not completely dynamic, but we can do this. But let's understand. Okay, I hate to do this copy paste, but still. Value. Okay, let's just do that later. Now let's append the value for now. We'll get back to this again. Return params, and then get params, and we'll just print the params that we get from the get params. Print params. Okay, it's a reformat file. Okay, now let's run this. Okay, guys, we are getting 0. So we'll also now add all the other fields like GRE, TOEFL, university rankings, SOP, LOR, CGP, research. So I have already done this. It simply takes time for me to do the same repetitive steps for other fields. So I'll just copy paste all the input divs to. I don't want to bore this video, so let's check. Okay, so now we have all the required uh, student details and information in our form. So now our work is to populate all the fields: TOEFL, university rating, uni rating, SOP, LOR, CGPA, and then okay, I will not put research here since it is a categorical field. We will put it into categorical fields. Alright. Okay. Okay, here cat field, so that's why I hate doing copy paste. Okay. Now what we'll do is, instead of just appending the values, actually have to auto encode it to number of classes and then append it. Let's just create this function, get categories. We'll pass in the value, so we'll import TensorFlow for that. Okay, return tf dot keras dot utils dot to categorical, pass the values and then number of classes, and number of research classes. Here it's just 2, so classes. Let's just define this constant to be 2. Okay, and then okay, this is I'll just convert it into a list. Okay, let's reform it again and then run this, and let's just check. Okay, oops, something is wrong. No, it's not append, it's actually extend. Let's just change it. Okay. Okay, so we should be having 8 values in this array. So 6 values, and then the 2 is on hot encoded values. 6 plus 2, 8. Okay, now we have got this get parameters functions ready. Now let's do prediction helper method. Get prediction, we'll pass in the params. So we still haven't started our prediction server. We'll do that in a while. I just wanted to complete all this flow before we go there. Let's do this get predictions. We'll pass in the params. Here we do actually make a post call. Let's import request, and we'll define URL constant, and then headers, content type, to be application JSON, and then accept. Again same application slash JSON, then HTTP. I do not remember this exactly. Let's just come back to that again. Data is nothing but instances, and then params. This is the format that we need to pass to TensorFlow serving server, and response of the post call. We'll pass in URL, we'll pass in JSON data, and then headers to be headers. headers. Okay, now let's print the response, or we'll just return the response and then print it here. Return response, print the prediction here, predictions. Okay, now let's prediction predictions. Okay, okay, let's reformat it again, and then let's check the flow, but we have not specified the URL. So this is the command that to actually start the prediction server. I'll just provide the link as well to how to install the TensorFlow model server. You can find it in the TensorFlow documentation itself. I'll provide the link in the description. You can follow this article and then install it. And here I'll mention 2501 as the port number. Model name to regression model. Model base path is same as what we have saved it in our while creating the model. So now our model is running. The server has started. Now we are good to make request to our TensorFlow model. Now let's just define the URL here. I'm completely not sure the file number. Slash something regression model, or let's regression model, or I'll just open my Postman, which okay. V1 slash regression models. I hope predict. Okay, now let's check models. Okay, I left the models. Okay, I hope it's fine. So let's try if it's working fine. Oops, something is wrong. Local host. I'll just copy this and paste it here. Okay, now maybe now it should work. Let's try it in Postman once, or yeah, it's working fine. URL looks good. I think here it should work. Okay, yeah, it does. Okay, we have got 200 response code. Congratulations, guys. We have integrated a Flask app which connects to our TensorFlow model. We are getting the predictions, but we have missed one thing here. We have not used we are not normalizing the data that we get from the form. So that part is left. So let's just print the JSON data. Okay, we're getting the prediction. Fine, shine. Okay, return. Let's just return predictions of 0 of 0. of 0. Okay. I think something is wrong. Dot JSON. I have missed dot JSON. Okay, now it looks good. Now let's get the prediction here. Prediction here, and let's pass this prediction value to our show.html. Okay. Let's go to our show.html. We'll just create a simple div to display our prediction. I'm not that good in the HTML. So let's just print this prediction. Admission chances or prediction. Okay, let's just save it and then run. Okay, it's not coming. Something should be wrong. Something is missing. Looks fine. It looks fine. Okay. Show.html extends space. Let me just put a horizontal line. What is wrong here? It's a very simple HTML div. It should work fine. Okay, it's not reflecting. I think something should be wrong. Maybe I'll just let me just print the prediction. Okay, let's debug for a while and then I'll just work something. Okay. I'm not sure with this, guys, so I'll just try do some trial error. Okay. Okay, but base is missing. Okay. What am I missing here? Everything looks fine to me, actually. I'll just revert it back. Let me try this again from one last time. Okay, it's not working. Maybe I'll just remove this section for now. Okay, let's just keep this for a while. Maybe we'll come back to it later. So one thing is, like, we are getting the prediction from our TensorFlow model. So let's just enter the valid value and just see our prediction. Okay, 18, 118, 4, 4.5, 4.5, 9.65, 6 5 and 1. Okay, something is wrong. Nearest value. Oh, it's not allowing me to enter fraction here. Okay, again. Maybe I have specified type to be number. Let me just check. As I said, I'm not a pro in HTML. Let me just check. Steps. Probably I should be providing steps. Yeah, I think step. I should be giving step as any, I suppose. Let me just go to base.html. Type is number here. Okay. Yeah, it's number. I'll just pause the video. Like, okay, yeah, it is actually the steps. Like, I mean, I have to provide steps. I have also, so I have, as you can see, I have added steps to all the form fields, and let's just is it? I think it's running here. Let me just refresh. Okay. 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 Let me just enter it again. Now it should work actually, because I have specified steps to be any, so I should be able to enter any fractions, floating value, step any, as you can see here. Four, 4.5, 4.5, 9.65 and 1. Okay, so we are getting predictions to be 62.6, so which is wrong. This is because we have not normalized the data. Our expected value is 0.92, but we are getting 62. So let's just normalize the data before we pass to our TensorFlow model for prediction. 62. Okay, to prediction. Now I'll import pandas. Pandas. We'll stats file. You should be aware of this. Like in the first part of the video, we had defined this. Sorry, saved the file. Now let's read that CSV into a data frame. Now we'll just normalize. Params minus stats of mean divided by stats of standard deviation. Okay, I'll just show you what I just did. So this is what I'm doing, scaling the data frame. So this is the file that we shared in the first part of the video, and then we're normalizing it in that way. And even while prediction, we'll have to scale our input data and then pass it to make a prediction. Okay, let's just convert it into a numpy array. Stats, sorry, params. We'll import numpy here. Okay, yeah, let's I doubt this. Yeah, okay, now let's get back to the code. I know what is the issue here. We'll just convert back again to list. Okay, let's refresh it. Check again. Okay, let's give the actual values. 37, 118, 4, 4.5, 4.5, 9.65, and then 1. Okay, let's submit it. Okay, 0.946, expected values 0.92. Okay, it's good. Okay, I think we are done. This is it, guys. Like, we have completed the complete flow from normalizing the input data and passing the data to the TensorFlow model and getting back the prediction. This is a simple application that we just built. Let's try one last input data. Let's 4.5, 8.87, and then 1.72. Okay, 0.76 is the expected value. So it looks good. So you can see the data is getting normalized, and then prediction value. And yes, pretty much it, guys. You can do the things that you like, and do share the comments or any suggestions that you may have.